Jake. Jake. Jake, where are you? Oh, hello, Vsauce. How you doing? What a surprise. I wasn't expecting you so soon. You're probably wondering where Jake is, right? Well, this is awkward. I think maybe I shrunk him. I mean, don't worry. I'm sure we'll find him. And it's not like shrinking down to the size of an ant can be a bad thing, right? You know, describing things is usually Jake's department. But I do wonder, what would happen if you were shrunk?
Oh, Vsauce, thank goodness you found me, because being reduced in size to half an inch tall is absolutely bad for you. In fact, if you were shrunk to this size, there are a few directions it could go. Let's suppose that only your size would change, but your mass, the amount of matter that you're made up of, stays the same. You'd be very dense. About 150,000 times more than the densest material we've ever found on Earth, osmium. Being that dense would be a massive problem. With your ant-sized proportions, you'd be exerting all that weight over the same area as just one pixel on the display that you're currently watching this video on. Hello. Only materials like diamond or carbon fiber could sustain such pressures without cracking due to your presence. In fact, your density is on scale with a white dwarf, a star that's used up all its hydrogen and collapsed in on itself due to gravity. Imagine the entire mass of the sun fitting into something as relatively small as the Earth.
What? What? He's too small. I can't hear what he's saying. I can't even read his lips. What are you saying? We can't. Repeat what you just said. Nope. No, I can't tell, but your voice is so high-pitched and cute. I love it. Say it again, just for my entertainment.
It's not my fault, Paul. At this size, your vocal tract is a lot smaller, so the vibrations have much shorter wavelengths. Typical male voices have frequencies of 85 to 180 hertz, but a shrunken man would talk at higher frequencies of 12 to 26 kilohertz. Since that's at the top end of the spectrum, you wouldn't even hear most of the words. In fact, digital audio for video can't contain any frequencies above 24 kilohertz because of the Nyquist limit. If I were to speak between 12 and 24 kilohertz, it would sound something like this. All very interesting, but this is us speculating that your mass would stay the same while being shrunk. And if that were the case, well, none of this would matter because your body would be crushed due to its inability to support your entire weight. You know, let's try the other option. If your mass scaled proportionally with your body, you'd weigh 0.03 grams, about the same as 10 snowflakes. As you can imagine, even a slight breeze of 8.5 miles per hour, about the same speed of a full-size human exhaling, could whisk you away. A sneeze would be even more damaging at 100 miles per hour. However, you might be able to outrun it. If we were able to scale ants up to human proportions, they'd be cruising around at 52 miles per hour. In fact, almost all micro-sized creatures would be moving really fast. The fastest recorded animal relative to its size is Paratarsotomus Macropalpis, a sesame seed-sized mite. It travels at 322 body lengths per second, the equivalent of a human running 1,300 miles per hour. And now that you're the size of an insect, you'd be faster as well, thanks to the Froude number. The Froude number is equal to the centripetal force involved in making your legs swing, divided by the gravitational force on your legs. So by shrinking yourself down and keeping your Froude number fixed, you'd be taking 12 times more steps than if you were full-sized. Add to the fact that your strides are now 66% bigger, you'd be 20 times faster than normal.
You know, I should probably figure out a way to bring Jake back to regular size, but this is just so fun. You're so fast, Jake. Running around like a bug. Run, Jake, run!
The one thing that could slow you down is water. At our ant scale, fluids act 21,000 times thicker than we're used to. It'd be like trying to swim through chocolate syrup, but less delicious. The good news is that you'd be able to walk on water. The surface tension would be able to support you without breaking. Ants do this all the time and also form tightly knit rafts to carry themselves across rivers. As long as the surface tension doesn't break, you won't suffer a slow, horrible, watery death. Let's go back to your increased speed and energy because it comes at a cost. Your metabolism would be ridiculous. To keep up with how quickly you'd be moving and the fact that the surface area of your body is relatively much larger than your actual body, you'd be losing a lot of heat. So you'd have to eat a lot, like every hour of every day. Your chances of survival are not great. But wait, hold on. I actually might have just figured out a way where I can get back to my normal size. Hey, Paul!
Jake! 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 Oh, Jake, I'm so sorry. Oh, I'm so sorry. Let me just get you off the lens. Oh, no. Oh. You know what? Jake, I'm just gonna go, okay? But as always, thanks for watching.
I'd like to thank Paul for joining me in a science adventure.
Oh, thank you for having me. I'm so sorry for all that I did to you, but I'm thrilled you're back and you're normal size and you brought me back here.
Thank you. Well, I'm actually a ghost now. But good news, even ghosts love seeing movies like Ant-Man.
I love how you did that.
Right?
Really, really good. I'd like to give you a parting gift, a thank you.
Oh?
This wire bowl of oranges.
Oh my goodness. Can we?
Cheers.
Cheers.
These have gone bad.